The story of America's greatness often focuses on traditional markers of power, military strength, economic output, or political influence. Yet one of the most profound contributions America has made to human civilization emerged not from battlefields or boardrooms alone, but from research laboratories, university campuses, and the collaborative spirit of scientists and engineers who dared to imagine a connected world. The development and expansion of the Internet stands as one of America's most transformative gifts to humanity, fundamentally altering how we communicate, learn, conduct business, and understand our place in the global community. When we examine why America is great through the lens of Internet development, we discover a narrative that embodies the nation's core strengths: investment in fundamental research, tolerance for risk and failure, protection of free expression, entrepreneurial dynamism, and the ability to turn theoretical concepts into practical applications that serve billions of people worldwide. The Origins: American Innovation and Government Investment. The Internet's creation story is quintessentially American, beginning with a government agency's willingness to fund ambitious, uncertain research. In 1969, the Advanced Research Projects Agency Network, known as ARPANET, sent its first message between computers at UCLA and Stanford Research Institute. This wasn't a private venture seeking immediate profits, but a publicly funded project exploring how computers might communicate across distances. The Defense Department's ARPA, later renamed DARPA, invested in this research without demanding immediate returns. This patience with fundamental research represents a distinctly American approach that has yielded extraordinary dividends. The scientists and engineers working on ARPANET weren't building a commercial product. They were solving theoretical problems about packet switching, network protocols, and distributed communication systems. By 1971, ARPANET connected 15 nodes with 23 host computers across the United States. Ray Tomlinson, an American computer programmer, sent the first network email that same year, choosing the @ symbol to separate usernames from computer names, a convention we still use today. These early developments occurred in an environment that valued open collaboration over proprietary secrecy, another hallmark of American scientific culture. The National Science Foundation expanded this network through the 1980s with NSFNet, deliberately creating an academic backbone that would eventually support commercial traffic. This government investment in infrastructure, coupled with a hands-off approach to content and use, created the conditions for exponential growth. The protocol revolution setting global standards. America's contribution to Internet development extends beyond hardware and funding to the very languages computers use to communicate. The Transmission Control Protocol and Internet Protocol, collectively known as TCP/IP, were developed by Americans Vint, Cerf, and Kahn in the 1970s. Adopted as the ARPANET standard in 1983, these protocols became the foundation of Internet communication worldwide. What makes this achievement remarkable isn't just technical brilliance, but the decision to make these protocols open and freely available. America could have patented these technologies, creating proprietary systems that might have generated revenue but would have fragmented global connectivity. Instead, the openness of TCP/IP allowed anyone, anywhere, to build compatible systems, ensuring universal interoperability. Tim Berners-Lee, working at CERN in Switzerland, built the World Wide Web on top of these American-developed protocols in 1989. But the web's explosive growth occurred largely due to American contributions. Mark Andreessen and Eric Beiner at the University of Illinois created Mosaic in 1993, the first widely popular web browser with a graphical interface. Andreessen later co-founded Netscape, bringing web browsing to mainstream consumers. These developments illustrate how American research institutions, even public universities, could rapidly transform theoretical work into practical applications accessible to ordinary people. The speed of this transformation, from research to commercial deployment, reflects an ecosystem uniquely suited to innovation. The entrepreneurial explosion, building the digital economy. The mid-1990s saw an extraordinary flowering of Internet entrepreneurship, predominantly centered in America. The combination of venture capital, technical talent, relatively light regulation, and a culture that celebrated risk-taking created conditions nowhere else could match. Consider the companies founded during this period. Amazon began in Jeff Bezos's garage in 1994, initially selling books online, but envisioning a comprehensive digital marketplace. Google emerged from Stanford University research in 1998, with Larry Page and Sergey Brin developing algorithms that revolutionized information retrieval. eBay launched in 1995, creating person-to-person online commerce. Yahoo, founded in 1994, organized the early web's chaos into navigable categories. These weren't incremental improvements to existing business models, but entirely new paradigms for commerce, information access, and human connection. By 2000, despite the subsequent dot-com crash, the foundation for digital transformation had been irreversibly established. The venture capital model that funded these companies represents another American innovation. Silicon Valley's unique ecosystem, where experienced entrepreneurs mentor new founders, where failure is treated as education rather than disgrace, and where ambitious visions receive serious funding, has no true equivalent elsewhere. Sequoia Capital, Kleiner Perkins, and other venture firms didn't just provide money, but networks, expertise, and credibility. America's bankruptcy laws, which allow failed entrepreneurs to discharge debt and start fresh, contrast sharply with many countries where business failure carries lifelong consequences. This legal framework encourages the risk-taking essential to innovation. Many successful tech entrepreneurs failed multiple times before achieving breakthrough success. While innovation captured headlines, America's less visible contributions to internet infrastructure proved equally crucial. American companies laid the majority of undersea fiber optic cables that form the internet's physical backbone. As of 2025, American firms remain dominant in submarine cable systems, with Google, Meta, Microsoft, and Amazon investing billions in new cable projects. These infrastructure investments connect continents, enabling the global internet. The first transatlantic fiber optic cable, TAT-8, became operational in 1988, with significant American involvement. Today, hundreds of cables crisscross ocean floors, with American companies owning or co-owning substantial portions. Domestically, American telecommunications companies, despite criticism about coverage gaps and speed in some regions, built extensive broadband networks. According to recent Federal Communications Commission data from December 2024, approximately 95% of American homes and small businesses have access to broadband internet service with speeds of at least 100 Mbps download and 20 Mbps upload, though important disparities remain between urban and rural areas. The Infrastructure Investment and Jobs Act of 2021 allocated $65 billion to expand broadband access, representing continued federal commitment to universal connectivity. Data centers, the physical locations where internet services operate, concentrate heavily in America. Northern Virginia hosts the world's largest concentration of data centers, with Oregon, Texas, and California also serving as major hubs. These facilities, consuming enormous amounts of electricity and requiring sophisticated cooling systems, represent tens of billions in American infrastructure investment. The second wave of internet innovation, often called Web 2.0, saw American companies create platforms that fundamentally changed human social interaction. Facebook, founded by Mark Zuckerberg at Harvard in 2004, now connects nearly 3 billion monthly active users worldwide. Twitter, launched in 2006, created new forms of public discourse, enabling direct communication between public figures and ordinary citizens. Instagram, founded in 2010 and acquired by Facebook in 2012, made visual communication central to online identity. These platforms emerged from American college campuses and garages, growing into global phenomena that transcend national boundaries. YouTube, founded in 2005 and acquired by Google in 2006, became the world's second-largest search engine and a platform where anyone could broadcast to global audiences. Critics rightfully point to these platforms' problems: privacy concerns, misinformation spread, mental health impacts, and political manipulation. These challenges are real and serious. However, they don't negate the fundamental achievement, creating technologies that allow unprecedented human connection across geographic, cultural, and linguistic boundaries. A farmer in rural India can watch educational videos on agricultural techniques developed at American universities. Political dissidents can organize movements despite government censorship. Families separated by oceans can maintain daily contact. Scientific researchers can collaborate in real time across continents. These capabilities, taken for granted today, were science fiction merely 2 decades ago. American companies pioneered cloud computing, fundamentally changing how businesses and individuals access computational resources. Amazon Web Services, launched in 2006, allowed companies to rent computing power rather than build expensive infrastructure. Microsoft Azure and Google Cloud Platform followed, creating a market experiencing explosive growth. Cloud computing democratized access to sophisticated technology. A startup in Kenya can access the same computing power as a Fortune 500 company, paying only for what they use. This levels playing fields globally, allowing innovation to emerge from anywhere with internet connectivity. The implications extend beyond business. Scientific research, requiring massive computational power, once limited to well-funded institutions, became accessible to smaller universities and independent researchers. Machine learning and artificial intelligence development, requiring enormous processing capabilities, became feasible for organizations of all sizes. American companies dominate this space. According to data from mid-2025, Amazon Web Services holds approximately 30% of the global cloud infrastructure market, Microsoft Azure holds about 20%, and Google Cloud holds approximately 13%. This dominance reflects not just technical capability, but business model innovation, creating services that scale globally while serving diverse local needs. While mobile phone technology developed globally, American companies and innovations proved crucial in mobile internet expansion. Apple's iPhone, introduced in 2007, didn't invent smartphones but reimagined them as powerful computing devices. The App Store, launched in 2008, created an ecosystem where millions of developers could reach billions of users. This platform approach, allowing third-party innovation on top of foundational technology, exemplifies American internet development philosophy. Apple and Google, through Android, created operating systems and app distribution platforms that enabled unprecedented mobile software innovation. As of 2024, there are approximately 4.88 billion smartphone users worldwide, with mobile devices accounting for a significant portion of web traffic. Mobile internet brought connectivity to billions in developing nations who never owned computers, enabling digital inclusion on an unprecedented scale. American companies and technologies facilitated this transformation. Qualcomm, an American semiconductor company, developed many fundamental technologies enabling mobile communication. American social media platforms optimized for mobile use, with companies like Meta acknowledging that mobile users far outnumber desktop users. Cybersecurity and internet governance. America's role in internet security and governance presents a more complex picture. American agencies and companies lead in cybersecurity research and technology development. The Computer Emergency Response Team, established at Carnegie Mellon University in 1988, pioneered coordinated vulnerability disclosure and incident response. American universities and companies conduct cutting-edge cryptography research, developing technologies that protect online transactions, communications, and data storage. The National Institute of Standards and Technology sets cryptographic standards used globally. However, revelations about National Security Agency surveillance programs raised legitimate concerns about privacy and government overreach. These controversies sparked important debates about balancing security, privacy, and freedom. Debates that continue shaping internet governance globally. The multi-stakeholder model of internet governance championed by American organizations and policymakers contrasts with authoritarian models favoring government control. ICANN, the Internet Corporation for Assigned Names and Numbers, transitioned from US government oversight to international multi-stakeholder governance in 2016, reflecting American commitment to distributed rather than centralized control. This governance philosophy, emphasizing openness and distributed authority, has helped preserve the Internet's fundamental character as a decentralized network resistant to single-point control or failure. Artificial intelligence and the next frontier. American leadership in artificial intelligence represents the latest chapter in Internet development. While AI research occurs globally, American companies and institutions remain at the forefront. OpenAI, founded in San Francisco, released ChatGPT in November 2022, demonstrating AI capabilities that captured global imagination. Google's DeepMind, Anthropic, and other American organizations push boundaries of what AI systems can achieve. These developments build on decades of American investment in machine learning research. Deep learning techniques that power modern AI emerged from work at American universities and companies. The computational infrastructure enabling AI training relies heavily on American cloud computing platforms and semiconductor designs. As of 2025, the AI industry continues rapid evolution, with American companies leading in both fundamental research and commercial applications. This leadership reflects sustained investment in computer science education, attraction of global talent, and ecosystems supporting high-risk research with uncertain timelines. Economic impact and job creation. The Internet economy, its economic impact illustrates America's successful translation of research into prosperity. The Internet has transformed economic activity across all sectors, though precise measurements of its total contribution vary by methodology. Employment in Internet-related fields has grown dramatically, with software developers, cybersecurity specialists, data scientists, digital marketers, and countless other roles emerging from Internet development. American tech companies rank among the world's most valuable. Apple, Microsoft, Alphabet, Amazon, and Meta collectively represent trillions of dollars in market capitalization. This wealth creation, while concentrated, has broader economic effects through employment, investment, and innovation spillovers. Small businesses benefit enormously from Internet technologies. A boutique clothing maker in rural Montana can sell globally through online platforms. Service providers can find clients worldwide. The barriers to entry for entrepreneurship have fallen dramatically, enabling economic opportunity previously unimaginable. Global influence and soft power. America's Internet development success enhances its global influence in ways traditional power metrics cannot capture. American platforms shape global discourse. American technology standards become de facto international standards. American companies' decisions about content moderation, algorithm design, and feature development affect billions globally. This represents soft power, the ability to influence through attraction rather than coercion. People worldwide use American Internet services not because they must, but because these services provide value. English became the Internet's dominant language, partly through American platform prevalence. Though translation technologies increasingly enable multilingual access, American values of free expression, innovation, and individual empowerment became embedded in Internet architecture and platform design. These values spread globally through technology adoption, influencing cultures far beyond American borders. Critics note, this influence can constitute cultural imperialism, imposing American norms globally. This concern deserves serious consideration. However, the Internet's open architecture also enables voices from everywhere to reach global audiences, creating countervailing forces to any single nation's dominance. Challenges and areas for improvement. Honesty requires acknowledging where America falls short in Internet development and deployment. The digital divide persists, with rural and low-income Americans lacking reliable high-speed access. While overall coverage has improved significantly, millions remain excluded from digital economy opportunities. American broadband speeds lag behind several Asian and European nations. South Korea, Singapore, and Hong Kong typically rank above the United States in connection speeds and infrastructure quality. American consumers often pay more for Internet access than counterparts in other developed nations, suggesting market failures requiring policy attention. Privacy protections in America remain weaker than the European Union's General Data Protection Regulation. American companies' data collection practices, while enabling free services, raise legitimate concerns about surveillance capitalism and individual autonomy. Competition in certain internet sectors has declined, with a few large companies dominating search, social media, cloud computing, and other markets. This concentration potentially stifles innovation and reduces consumer choice, requiring antitrust enforcement and regulatory attention. Despite these challenges, America's foundational contributions to internet development remain undeniable and transformative. American universities continue training global technology leaders. Computer science programs at Stanford, MIT, Carnegie Mellon, Berkeley, and numerous other institutions attract the world's brightest students. Many international students educated in America remain, contributing to American innovation while maintaining global connections. This brain gain, while beneficial for America, raises equity concerns. Developing nations invest in educating talented individuals who then migrate to America, creating brain drain that perpetuates global inequality. However, many returnees bring skills and connections back home, potentially creating positive spillover effects. American commitment to STEM education, while imperfect, continues producing technical talent. Initiatives promoting coding education, even in elementary schools, prepare future generations for technology-driven economies. Organizations like Code.org, founded in America, promote computer science education globally. Research funding through the National Science Foundation, Department of Energy, National Institutes of Health, and other agencies sustains the basic research underlying internet innovation. This sustained investment in fundamental science, without demanding immediate commercial applications, enables breakthroughs that eventually transform industries and societies. America's greatness in internet development stems from multiple factors working in concert. Government investment in fundamental research, entrepreneurial culture embracing risk, legal frameworks enabling innovation, educational institutions producing talent, openness to global collaboration, and commitment to relatively free and open systems. The internet emerged from American innovation but belongs to humanity. American decisions about internet technology, governance, and policy affect billions globally. This creates responsibilities extending beyond national interests to consider global welfare. As we advance toward increasingly AI-driven, interconnected futures, American leadership in internet development faces new tests. Will American institutions continue investing in fundamental research? Will American companies balance profit with social responsibility? Will American policymakers craft regulations protecting individuals while enabling innovation? Will America remain open to global talent and collaboration? These questions matter because internet development continues shaping human civilization. The next decades will determine whether connectivity deepens understanding or division, whether digital technologies empower or exploit, whether artificial intelligence serves humanity or concentrates power dangerously. America's track record in internet development, while imperfect, demonstrates capacity for transformative innovation benefiting billions. The challenge now is sustaining this innovative capacity while addressing legitimate concerns about privacy, competition, equity, and social impact. Why is America great? In internet development and expansion, greatness emerges from creating technologies and systems that transcend national boundaries, connecting humanity in ways previously impossible, enabling economic opportunity across geographic and social barriers, and establishing open standards allowing global participation. This greatness brings obligations. Having helped create the connected world, America bears responsibility for ensuring this world serves human flourishing broadly, rather than narrow interests. The ongoing story of internet development will reveal whether America can meet these responsibilities while maintaining the innovative spirit that launched the digital revolution. The internet's future remains unwritten. American choices will substantially influence how this future unfolds, for better or worse. That influence itself testifies to America's greatness in internet development, while simultaneously demanding wisdom, humility, and commitment to human welfare over purely national or commercial interests.